Hi everyone, welcome to Study with Akshay, and this is Akshay. In this video we are going to continue with the numerical questions from 7th problem we are going to continue. So basically the previous numerical problems are already uploaded in a playlist. You can go back to that, watch that and come back to this. So before getting started, if you are not subscribed to my channel, please do subscribe and click on the bell icon to get regular notification. Let's not waste time. Let's get started. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw a diagram to show the application of forces and calculate the moment of force applied. So it is the diagram basically. So basically when we hold the steering wheel, one side we will apply the force and the other side will be a complementary force which will be applied. So it is a type of a couple basically. Okay, and then diagram has been drawn. Along with that, let's calculate the moment of couple is equal to either forces. So 5 Newton into the couple arm is 0.5 meter. So 5 Newton into 0.5 meter, that is 2.5 Newton meter, is the moment of couple. So since it is a couple, so we cannot call it as moment of force. Instead, we call it as moment of couple. Hope you have understood this question. Let's move ahead further. A uniform meter rule is pivoted at a point at its midpoint. A weight of 50 GF is suspended at one end of it, where a weight of 100 GF should be suspended to keep the ruler horizontally. So basically, such kinds of meter rule problems are basic questions or most important question which can come, and most expected too, which will come in the board examination. So let's be aware of the questions and then let's concentrate on such kinds of questions in order to be in the safer side. So in the pre-board questions, while we are making the videos of pre-board questions, you can expect every year is having a meter rule question. So imagine how important it might be. So let's get started. Let the 50 GF weight produce anti-clockwise moment about its middle point of a ruler, that is at 50 centimeter. A uniform meter rule means 100 centimeter rule. Okay, 100 centimeter makes 1 meter. So uniform meter rule, a uniform, they have not ruled half. So a uniform meter rule means one complete meter rule. So at the center point, the basically it is pivoted at the middle point 50 centimeter. So 50 gs weight produce anti-clockwise moment. This is our assumptions. So let the weight of 100 gs produce clockwise moments about the point, and let the distance from the middle be d centimeter. So basically, so if it when it is at 50 GF, when the weight of 50 GF is suspended, it produces anti-clockwise movement. So when the weight of 100 GF is suspended, it produces clockwise movements. So from 50 GF to the pivoted point, it is 50 centimeter, and from 100 GF to the pivoted point, we are assuming it as d centimeters. So according to the principle of moments, anti-clockwise moments is equal to the clockwise moments. So 50 GF into 50 centimeter will give you 100 GF into D. So upon the simplification we get 25 centimeter from the other side. So basically, if you are suspending, imagine this is a meter rule and it is suspended over here somewhere, and towards this side, towards its anti-clockwise movements, right? Okay, towards its left side 50 GF is suspended, and towards its right side somewhere, not exactly at the end, in the middle somewhere, 100 GF is suspended. So uh, from there till this it will be 25 centimeter is the distance. Hope you have understood this kind of question. This is most simpler kinds of questions which will be asked, and most scoring questions. Please to concentrate on such kinds of questions. Let's move ahead further. A uniform meter rule balanced horizontally on a knife edge placed at the 58 centimeter mark. When the weight of 20 GF is suspended from one end, draw a diagram of the arrangement. So please don't simply waste time by drawing the diagram unless and until they ask the diagram. In the previous question, I did not draw the diagram because they have not asked the diagram. So simply don't draw. If you want more clarity, if there is no wrong in drawing, you can draw it. Since the revision what I do would be sufficient, so you will have more and more clarity regarding the meter rule concepts. So after solving the pre-board question, also you get more and more confidence as well that you can block the meter rule problems. So by just seeing the question, you can assume the diagram. So there is not required to draw a diagram as well, as per my point of view. So I did not draw it for the previous one. So for this one, they have only asked, so it is a compulsion. 1 mark will be given for the diagram, or else you will be losing 1 mark. So let's draw the diagram. So this is the diagram basically. uh, 58 centimeter mark it is pivoted, and 20 GF is suspended at one end. So it can be either this end or this end, but basically we take always at 100 centimeter suspension. And then in order to balance at 50, there is some weight suspended. What is the weight of the meter rule required? So basically let's start solving. So weight W, basically that is mgh is the W of the meter rule, which is anti-clockwise movements of the knife at the point O. If in order to balance it, 20 GF must be suspended at the end B to produce clockwise movements of the knife. So this is for the first question explanation basically. So according to the principle of moments, anti-clockwise moments is equal to clockwise moments. So 58 W into 58 minus 50, and then 20 GF into 100 minus 58. So W into 8 is equal to 20 into 42. Upon simplification, we get W is equal to 0.5 GF. So at this point, basically at this point, 0.5 it's not 0.5, it is 105. Sorry for the inconvenience. It is 105 GF will be suspended. Please don't wonder why I spoke for 0.5. It is 105 GF will be suspended at this point. Okay, let's move ahead further. The diagram shows a uniform bar supported at the middle point O. A weight of 40 GF is placed at a distance of 40 centimeter to the left of the point O. How can you balance a bar with a weight of 80 GF? Diagram, basically they are not given, we have to draw the diagram for this. So upon drawing the diagram, we understand at this point 40 GF is there. So 80 GF, in order to balance it, where should it be placed? Anti-clockwise moments is equal to 40 GF into 40. So clockwise moment is 80 GF into d centimeters. So according to principal moments, anti-clockwise moments is equal to clockwise moments. So 40 GF into 40 equals 80 GF into d. Upon simplification, we get 20 centimeter on the right point of O. So at this point, basically, it will be suspended. Okay, 80 GF should be suspended at this point in order to balance the meter rule. Let's move ahead further. Figure shows a uniform meter rule placed on a fulcrum at its midpoint O and having a weight of 40 GF at 10 centimeter mark and a weight of 20 GF at 90 centimeter mark. You can see the picture over here. As in when I read the question, you can see the picture which is displayed on the right hand side so that you can make it easy. Is the meter rule in equilibrium? If not, how will the rule turn? How can the rule be brought into equilibrium by using addition of weight of 40 GF? So basically, for the first question, anti-clockwise moments is equal to 40 GF into 50 minus 10, that is the distance. So 40 GF into 40, that is 1600 GF centimeter is the anti-clockwise moments. So clockwise moment will be 20 GF into 90 minus 50, that is 40. 20 into 40 is 800 GF centimeter. So now anti-clockwise movements is not equal to clockwise movements, hence the meter rule is not in equilibrium. So this is the first question answer. So in if not in if it is not in equilibrium, in which direction will it turn? Now ask. Basically, more wherever the more the moment is there in towards that direction it turns. So anti-clockwise movements is greater than the clockwise movements. So in the anti-clockwise direction it turns. Now coming to the second question. To balance the meter rule, 40 GF of weight should be kept at the right hand side so as to produce a clockwise moment. About the middle point, let the distance from the middle point be how much centimeter? D centimeter. So basically towards this side, basically it should be placed. So to the right hand side, sorry, not towards the left side, to the right hand side, since anti-clockwise is more already, so towards the right hand side it should be placed, so get it into equilibrium. Then clockwise moments will be 20 gf into 40 centimeter plus 40 gf into d centimeter. So we know according to principal moment, anti-clockwise moments will be equal to the clockwise moments. So 40 GF into 40 centimeter will be equal to 20 GF into 40 plus 40 into T. So upon simplification, we get 1600 minus 800 equals 40 GF into D. So D is equal to 800 by 40, which will be 20 centimeter on the other side. Hence, it is placed, additional weight placed at 40 GF at the point 70 centimeter mark of the rule that can be brought at equilibrium. So basically it is 20, 50 plus 20 is 70 at this point. Basically at this point the meter rule weight must be placed. Okay, let's move ahead further. When a boy of weight 20 kgf sits at one end of 4-meter long seesaw, he gets depressed at its end. How can it be brought into a horizontal position by a man weighing 40 kgf? So basically, according to principle of moments, anti-clockwise moments should be equal to clockwise moments. So I repeat over here, they have not asked this to draw a diagram, so I'm not drawing the diagram over here. So 20 kgf into 2 meter, which is equal to 40 gf into d. D is the distance. Where should the man be sat? Basically, so already he is sat on the one end of it. So where should the ball be sat? So in order to break it into an equilibrium position, upon simplification, we get D is equal to 20 kgf into 2 meter divided by 40 kgf, which is equal to 1 meter from the center on the side opposite to that of a boy. Hope you have understood the concepts. If you have liked this video, please click on the thumbs up button. You can share this video. If you have anything to comment regarding the video, you can comment using the email ID studywithakshay65@gmail.com. Stay home, stay safe. Next video will be the continuation of the numericals part. From the 13th question we will be starting, and that will be the end of the new exercise numericals basically. After that we will be going ahead with the example numericals, and then let's see. Uh, okay, you people can support me by by this way, and thank you. Have a nice day.